Welcome, folks. Monday morning, huh? Whew. After a rainy Sunday, hopefully it gets nice enough out for you to be able to venture outside today. Today we're basically going to talk about concave mirrors. So on Thursday we talked about flat mirrors, angle of incidence equals angle of refraction. I know today I was supposed to do a flat mirror lab. I got to figure out how I want to do that, just because I don't imagine a lot of you have flat mirrors. So that's going to be a little bit more of a challenge than I had originally anticipated. So today what we'll do is we'll talk about concave mirrors, and then we'll draw a few. Tomorrow you'll have some homework from today's lecture, and I'll sit in my virtual classroom. If you want to come in and work on that together, we can. Also, if you just want to say hi, that'd be awesome too. All right, here we go. Okay, so when we look at concave mirrors, all right, so for us now, this is a spherical mirror. So there's a couple key points that I want you to be aware of. Oop, let me start my PowerPoint here so we get the animations and all that good stuff. Full screen. All right, so there's our spherical mirror. All right, so what we're going to see here is there are 2 points that are important for our spherical mirror. All right, the 2 points that are important for us are going to be our focal point and our center of curvature. All right, so our focal point is just a place where if we send in just parallel lines, that's where it's going to meet, is that focal point. Okay, the center of curvature is if we were to extend this mirror all the way and keep that same angle, that would be the center of the mirror. If we were to create like a geode or a completely circular mirror, that's where our center of curvature is going to be for us. All right, so just remember those 2 points because those become kind of crucial for us as we start to draw stuff on here. All right, so rules for reflection. Now, drawing this, again, remember, when we look at how to draw for different images, whether it was a concave or a convex lens, when we use the thin lens equation, we had 3 rules. All right, so rays that enter the mirror, sorry, parallel to the principal axis are reflected through the focal point F. So as they come in flat according to the principal axis, they hit the mirror and then go back down through the focal point. All right, through the focal point are then reflected parallel. So these are the 2 really, really good rules that we're going to use probably more often than not. And they both involve that concept of being parallel. So this one will be through that focal point and then end up going out parallel. The third one, this one's a little trickier. Through the center of the lens, or through the center of the mirror, and then reflected back through C. So that's through that midpoint of where that mirror would be a circle at. All right, this one, unfortunately, at times we don't get. Remember, you just need 2 of these 3. If you can draw 2 of these 3, then you got the image and where it's going to form. Okay, so let's try one out. All right, so if we put a pencil right there, okay, so notice erasers on the principal axis or center axis. Okay, there's our center point of it, there's our focal point. All right, so first one goes down and through, right, parallel to the principal axis. Once it hits the mirror, then we adjust and we draw it down through there. All right, if you're doing this on a Google Doc, somebody shared with me, you can hit the shift button and that will allow you to draw a straight line there. All right, meaning that it'll draw it parallel. Then we just have to be able to click on the tail or on the head of this one and then just draw it down through there. Okay, that gives us a plausible location that we should probably see this forming down here. Okay, second one, through the focal point, and once it hits the mirror, then it's going to go parallel out. All right, now notice we got a special point right here already. Okay, that point right there is going to be very, very crucial for us. Like we saw when we had our lenses, a point in which these 2 lines cross is where an image is actually going to form for us. All right, so now let me show you something that's a little bit different, okay? There's our C point, right? So now we have real confirmation for us, okay? Now, just a little tidbit for you if you wanted to think about this. You could draw really any line as long as it comes back and we have like the normal, if you remember what the normal is, and the angle of incidence equals the angle of refraction, you're good. I'll show that later. Right now, do not worry about that yet. Okay? So notice the image right there. Okay? As we draw the image, notice how it looks from the eraser here to the eraser there, right? Both erasers are on that principal axis. Okay? The tip of the pencil is drawn through the points and where these three hit. Now, if the three don't hit perfectly, it's absolutely okay. All right, don't freak out. Find the area approximately where all three of those are going to meet. Okay, that becomes the biggest, most important part for us. All right, so they converge where the tip of the pencil forms, like we talked about, right? Since we place the eraser on the principal axis, the image of the eraser forms on the principal axis. All right? Again, that means this thing formed here or was placed there. So here, that has to be placed there as well. Now, please be aware, this is a point of contention with me. This is a little detail that I look for every once in a while when I'm grading these homework questions or these quiz questions or these test questions. Is it actually on the principal axis? Or did you just draw something where you drew that pencil like that? Where you didn't actually touch it, okay? That one, I can get a little snarky and I can get a little bit upset. I might take points off, but I would prefer not to. So just draw the eraser, in this case, on the principal axis, okay? All right, so then we ask the question, which you already saw the answer to. Is this a real or virtual image? This one should be a real. If the light actually goes through it, if the light actually hits this after it goes through the lens or goes through the, gets bounced off of the mirror, then that is a real image, meaning that it actually does form that, okay? And this is why if you were holding up like that spoon like we saw, and you're holding it so that the curved portion of the spoon is facing away from you, that's why you're going to see a real image of you. Now, all right, so the image is real because the light rays actually converge where the image forms, okay? So then next we say, is it upright or inverted? Meaning that, is this image right here that we just formed upright or inverted? In this case, it's inverted, meaning upside down, okay? All right, let's try a different one. Now, notice a change here, all right? Big difference here is, look at our center of curvature. The pencil's inside of that. So the difficult part is using that third rule. The reason why that third rule is so incredibly challenging is going to be because that means we'd have to draw this thing that way, right? Which we're not going to do. So that third rule becomes something we can't do. And I'll show you the workaround for that one, okay? All right, here we go. Parallel and then down through the focal point, right? Just like we talk about. Notice angles are the same. So the angle here should be the same as the angle there, all right? Meaning that our angle of incident equals our angle of refraction or reflection in this case, all right off the normal point, okay, or off the normal, sorry. All right, here again, through the focal point, parallel out. Notice again, angle here, those two should be pretty similar, right? Angle in and the angle of reflection should be the same, just like we talked about if we had a flat mirror, right? We find that normal, right? The normal is the perpendicular line that is drawn onto the mirror or onto the lens, and it allows us to see that that is going to create the same angle in as it does out for us here, all right? Now, for those of us who need to follow rules, those of us who need to look at this and say, but there's a third point, we need to draw a third line, right? Even though we've got a really good point right there, I get it. right? So then what we can do is we can draw this one. Now, some of you are looking at this and saying, how did you choose that one? All right. Well, randomly. Okay. I've drawn the blue line here just following the basic rule of reflection. The incident and reflected are the same. This is just to show that you could randomly draw points from the tip of the pencil and still get the same concept, same idea, same rule placement, or same location of the image. That's all that means. Okay? So be aware of that. Because when we look at this, as this got inside the center of curvature here, what happened was we had to have, if you needed that third line, that's how we get the third line. Do we have to have it? Not at all. All we need are the first two. All right, so just to show you, that third one still does meet there. So then we draw our image in there. See? Now, it just so happens to fall near C, right? But we got the eraser right on the line. We got the tip of the pencil right on the point where all three of those cross. Okay? So then we're going to go ahead and ask a couple questions for you. Real or virtual? Yep, this one is real, because all of the light rays are actually converging on that one spot, right? They're crossing in that one location. Okay? What's our next one then? Right? Upright or inverted? Yep, this thing's inverted. Inverted because it's upside down. Upright would mean that this thing is actually on the top part of this, which is really, really tough for a concave mirror. Okay? All right. Here we go. Last one for the day. All right. This one is tough. I'm not going to lie to you. This one gets a little weirder. All right. And again, pay attention. I'm going to use the basic law of reflection. All right. Now, as we look at this concept here, the reason that I have to use this law of reflection is because I can't get to my focal point. Right? I can't draw a line parallel and then back through. Or actually, the second rule is probably the one that I can't do, right? Through and then parallel. It just doesn't work that way. So for this one, I just have to go back and kind of get my hands a little bit dirty. So what that means is I'm just going to draw my lines like this, all right? Again, my normal would be somewhere in that direction, right? Normal would end up being something, well, not like that, but a little bit more upright, okay? Same thing here. Normal is going to be somewhere like here, right, for that one. And then same thing, normal here. Oh, there they come. I knew I had the animation somewhere in there, right? Look at that second one. That second one's pretty dang good. That first one, I got the bottom of it drawn on point, right? The third one, oof, yeah, I learned. All right, so now tell me something about these three, right? The green, yeah, just so happened to hit here. Perfect, great, awesome, right? You could say that that's still our first rule, but look at the blue, look at the red, look at how these three are doing what? Yeah, they're diverging. Are those three ever going to meet up? No, because this one's going at an angle like that. That one's a slightly steeper angle, and that one's an even steeper angle than the previous two. So what ends up happening is that these things are going to spread way out. Okay? So because they're going to spread way out, we're not going to get a real image here. So does that mean that no image forms? No, not at all. That just means that if we look at this, that image is actually going to be on the opposite side. So the rays never converge. This doesn't mean an image isn't formed. If you take the reflected rays and trace them backwards to the right of the mirror, what does it look like? So because these three are diverging, going away from each other, that just means we don't get an image on this side. There's no image there. So then the image has to form somewhere over there. Okay? Well, let's look and see. All right, extend that one out. Extend the next one out. And extend the third one out. Now look. What you're seeing is these are getting pretty close together out there, right? So because of that, They all seem to form in that same spot. So what that means is we get that. That's a big pencil. Right? So now we're going to ask, does light actually come from this location? Does it matter for forming an image? Think about flat mirror. Remember, in a flat mirror, you can see yourself. So as I look at that flat mirror, I see myself. But am I actually seeing a real image of myself? Because the real image appears to be where? Behind the camera, behind the lens, behind the mirror, right? Even though the light doesn't go through there. You know what I mean? Meaning that if you've ever had a handheld mirror, right, the light doesn't go through that. It hits and bounces back away. That's how mirrors are made, which I'll share with you that how it's made from the Science Channel. I know, weird. All right? But for us here, this is not a real image. So then it has to be a virtual image. If it's behind the mirror like this, that's a virtual image. The light is not actually meeting there. It's what we perceive, what our minds are putting there for us. All right? So then we ask, upright or inverted? That one's upright. Okay? Now, does that mean that that image doesn't form? Not at all. It just means it virtually forms. So our mind has to construct that image as such. Okay? So, that's going to be it for today. All right? I know I've kind of blown your mind a little bit here today. You've spent enough time kind of looking at this stuff, and hopefully you drew a few things on your notes for you. Tomorrow, I'm going to spend the whole hour just drawing these. Okay? So, if you want to join in with me, I would love it. Absolutely adore it if you got on my virtual classroom. I'll send that address out today and tomorrow as well. So if you can be in during your hour, great. If you cannot, that's fine. Come in during a different hour. If you want to come in at 10 o'clock in the morning, great. That's perfect. All right. I'll have the worksheet ready early in the morning for you so that you can look at it and see what's going on with it. I'll also throw a couple different videos up onto my Google channel or my YouTube channel so you can see a few different things on how they do some stuff like that. Okay? Otherwise, folks, hey, hope you have a good day. Take care of yourselves, and I hope to see you tomorrow. Okay? Take care. Bye-bye.